Okay, so for the chain rule involves, when we use the chain rule, when we have one function inside of another function, called composite functions. Composite functions means when you have something inside of something else, okay? That's when we use that. And that happens a lot, happens more than you think. So how do we find derivatives of those things? Well, the reason I put M&Ms here is because think of an M&M. When you're biting into an M&M, right? This one is a peanut M&M, so it has 3 layers, right? It has the shell, which is chocolate. Then it has the chocolate filling, right? And then it has the peanut. It has 3 layers, right? A regular M&M just has 2 layers. The shell and the chocolate, right? Or whatever's inside. Okay? So when we're doing chain rule, that's essentially what we're doing. We're going layers deep. We start at the outside. We do the outside first. The outside's the shell. Then we leave the inside alone, right? When you crack that shell, the shell's cracked, but the chocolate inside or the peanut inside hasn't been touched, right? You leave that alone. Once you get done with that, then you chew into the next layer, whatever that is, right? And you keep going until all the layers are done, right? That's how we find derivatives of composite functions, which is why we use the chain rule. First thing we do is find the derivative of the outside. Rewrite the inside. Leave the inside the way it was. And then we go one step deeper. Then we take the derivative of the inside. Okay? So that's why it's called the chain rule, because there's different chains to it, right? First chain, derivative of the outside, leave the inside. Second chain, now we do the derivative of the inside. Okay, so the hardest part about this, I found, is not doing the derivative part. Doing the derivative part, students are good at it. You guys, because you guys are good at using the power rule. You guys are good at using the product rule, good at using the quotient rule. You know what the derivatives for trigs are, trig functions. We did that the other day. It's knowing what is the inside and what is the outside. Is this an inside or is this an outside? Or what is the outside? That's the biggest thing. Knowing what is the inside function and what is the outside function. Because sometimes there'll always be an outside function, but sometimes there's not only one inside function, there's 2 inside functions, and sometimes 3 inside functions. So the hardest part about doing the chain rule is, what are those things? So let me show you some examples. Right above that, I have 4 examples where we don't need to use the chain rule. Chain rule is not needed. You guys can do these. You guys can do each of these guys right now without knowing how to use the chain rule. Right? First one, you just use the power rule. Yep. Second one, you just use the trig, right? Cosine. This one, you use the power rule. Last one, you use just the same thing we've been doing, right? How can I tweak these so that now you do need to use them? Well, look what I did to the first one. What did I do to the first one to change it? So now it's got an inside and an outside. The inside is that. What is the outside? The root. Okay? So what is the inside? X squared minus 1. What is the outside? Everything. The outside's always going to be everything. So the outside would be the square root of x squared minus 1. Okay? So let's look at the second one. Sine of x, derivative is cosine, right? How is that one different? So now there's something to go along with the angle, right? Because the angle before was just x. Same thing here, right? Same thing on the last one. Now, there's layers to it. There's a sine of 5x. That's the outside. The inside is just 5x. The outside would be the whole thing. Okay? Or I should say the outside. The outside is the whole thing, but it's sine of something. Okay? The last one, the third one doesn't really go together, but you can see that there's an inside. And then the outside is something to the 7th power. What is to the 7th power? The inside, right? The inside. And then same thing with the last one. The last one, the outside, oops, x, negative tangent. The inside is x squared. So that is, believe it or not, that's the hardest part about this. It's not doing the derivative, because you guys have been doing derivatives for a few weeks. It's what is the inside, what is the outside, okay? So that's what we're going to focus on today. The big focus on today is, can I tell the difference between the inside function and an outside function, okay? So let's look at some. I got some practice problems here. Okay? So the first practice has nothing to do with calculus. We're not doing derivatives of anything right now. We're just trying to figure out what is the inside function, what is the outside function. Okay? So I always start with the inside, because the inside is probably the easiest to find. So the inside is usually going to be in parentheses, under a root, something like that, right? So the inside is 5x squared. That's going to be the inside. Then what is the outside? The outside is cosine of something, right? Of something. Cosine of something. Okay?
We just leave it blank or put it in?
Oh, you can put it in. You can put it in there if you want, but I'm just focusing on the separate. So you can put 5x squared in there. That's okay. There's nothing wrong with that. Okay? B. What's the inside? 3x plus 1. What's the outside? The square root of something, which happens to be 3x plus 1. So let's write this. Inside is 3x plus 1. Outside is the square root of that guy, right? And what do we always do with roots before we actually, I'm not doing it now because I'm not finding a derivative, but if I was going to do that, if I was going to find the derivative of b, what would I do first? Change it to a power, right? Change it to 1/2 power. So I would change it to g of x equals 3x plus 1 to the 1/2, right? That's what I would do first. I didn't do that now because I'm not finding derivative. Next page, when we're finding derivatives, we'll do that. Okay? All right, let's go to the next one. This one's a little tricky. Not because it's hard, but because it's trig. What does that squared mean? So, like I said, this is how they write squared in trig. Does it mean x is squared?
No.
No, it means the whole thing is squared, right? So what it's saying is this. Everything on the inside is squared.
So the inside would be sin x.
There you go. Once you write it like that, it's not as hard to see what the inside is and what the outside is. That's why it's still tricky. Okay. So the inside is sine of x. The outside is squared, something squared. Okay. Okay. Letter D. What would be the inside? What would be the outside? So we always look for grouping symbols. When we're looking for inside, we look for grouping symbols. Grouping symbols are things like parentheses, brackets, roots, fractions. This is actually a grouping symbol. The top is a group, the bottom is a group, right? If I wanted to find the derivative of this, what would I need to do first? Get rid of the fraction, right? So I would change it to this. Once you change it to this, it's easier to see. So what power would this be? -1. Once you change it to that, now it's easy to see what's the inside and what's the outside. That's one of the reasons why from day one I've been telling you guys to change things. If it doesn't have a power, give it a power, because I knew this day would be coming when we have to decide what's the inside and what's the outside. So when you do it that way, you can see, oh, the inside's 5x plus 1. The outside is something to the -1 power. So what we just did there is the hardest part. Trust me, it's the hardest part. Using the rule is not hard, because the chain rule is just another version of the power rule. We use it like we would the power rule. So the next page, we're going to use the same 4 plus some more, but we're going to actually now find the derivative. Okay? So let's go to the back. So A, B, and C, and D should look familiar. The others won't because they're new, but this one. Okay. What did we say was the outside for this guy? Outside, what color did I use? Was cosine, right? The outside was cosine, right? We said that. When we're finding derivatives, we start on the outside first. Just like when I'm eating an M&M, I can't start with the inside. I have to bite into the outside first, right? So all I'm going to do first is find the derivative of cosine. What's the derivative of cosine? Negative sine. What do I do? What do I do with the inside? Rewrite it. Rewrite it. I haven't got to the inside yet. I'm just focusing on the outside right now. So the derivative of the outside is negative sine. Rewrite the inside. Chain. We use, how do we, and here we just use a multiplication sign for a chain. That's the chain. That's why it's called the chain rule, because you chain on something. Now what do you think I'm going to chain on? Derivative of the inside. Now I'm ready for the inside. Derivative of the inside is going to be, 10x.
So we would just put 10x,
So yep,
negative 10x,
so you put negative 10x, move that to the front, times sine of 5x squared. And that is the derivative. So the hardest part about this is the order in which I find the derivatives. Not actually finding the derivatives. That was the easy part. It's the order. Which do I do first? Which do I do second? Okay? All right, let's look at B now. All right? What did we say the first thing to do with B was? Before I even did inside or outside? Rewrite it. To get rid of the root by rewriting it. So I have 3x plus 1 to the 1/2 power, right? Now I'm ready to find a derivative. What's the inside again? Let's start with the outside because you got to bite into the shell first. What is the outside? The outside was the root, right? So watch what I do. I don't care what's on the inside. I really don't care what's on the inside yet because I'm not there yet. How do I find the derivative of something to the 1/2 power?
you move it to the front,
I got to move the 1/2 to the front, right? And what do I do with the power? Subtract the whole power. So when I subtract the whole power, what's left?
negative 2.
-1/2, right? Rewrite the inside the way it was. I haven't cracked into the inside yet, so I'm going to rewrite the inside the way it was. chain.
Times 3.
Now that I've gotten into the outside, now I can move into the inside now. Now I'm going to find the derivative of the inside. The derivative of the inside is just positive 3.
And then you multiply the 1/2.
And then, yeah, and then you clean it up, multiply 1/2 times 3.
3/2.
So I'm going to make a fraction, so it's going to be 3 on top, 2 on bottom. I'm going to put the root back in. But it's a negative 1/2, so that's going to go to the bottom. So it's going to be root 3x plus 1.
Is that 2 root or is that 2 times root?
It's the same thing. 2 times root and 2 root are the same thing. Yeah, you could put a multiplication sign there if you want. So what happened to the 3 times 1/2? It's there, 3 and 1/2. The root moved to the bottom since it was negative 1/2, right? Done. That's done. Okay. Let's go to C. Again, in trig, they like writing squares there. This is not trig. This is calculus. We don't like writing squares like that. I'm going to write it how it's supposed to be, or how it's easier, I should say. Okay. Let's start on the outside. The outside is something squared. Something squared. So if you wanted to find the derivative of anything squared, what would you do? Yeah, just use the power rule, right? Move the 2 to the front, subtract a power, it's just 1, right? Rewrite what was on the inside. I haven't cracked open yet what was on the inside. Chain.
Cosine of x.
The inside only has one layer, sine of x. Now be careful. If that was sine of 2x or sine of 4x, then it would have another layer, but it doesn't because it's just an x. We'll see problems like that later. So now what's the derivative of the inside? Cosine. So if you have a power of 1, you don't need to write that. You can if you want, but you don't need to. So it's 2 times sine of x times cosine of x. That's the derivative. Done. Okay. Letter D. Change the way it looks.
Negative 1/2.
5x plus 1 to the negative 1 power. Right? So the outside was something to a negative 1 power. When you're first doing these problems, it does help sometimes if you have different colors to distinguish between the inside and the outside. It does. Because it's easy, the eye sees different colors better than it does, once you get good at this, then you can see the layers. But for early on, it might help to use different colors or markers or something like that to distinguish the inside from the outside. Okay? So the outside. So if you're looking at 5x plus 1, you're looking in the wrong spot for the inside. I don't care. I could frankly care less what was inside. I just know that there is something to a negative 1 power. How do I do a derivative of something to the negative 1 power?
Power rule.
Power rule. Move the negative 1 to the front, subtract a power. I haven't touched the inside, so I'm going to leave the inside alone. Chain. Chain means multiplication. Now that I've done the inside, I'm going to do the outside, I'm going to do the inside now.
5.
Which is just 5, right? The derivative of 5x plus 1 is just positive 5. Again, these are going to be multiple choice questions. You're going to see these on multiple choice tests. So you just have to get to a point where you can match one. Nothing, there will not be one of the letters that will have like this. It'll be simplified. So you can multiply the -1 times the 5 and you get -5. And then to get rid of the negative power, we got to move it to the bottom. So it'll be 5x plus 1 squared. That'll be how it looks like on a test. Done. Okay. So now I gave you three problems. Now I gave you 3 problems which you haven't decided. We haven't seen yet, right? Those last 4 we saw on the last page. These we haven't seen yet. Okay? So let's see. Try letter E on your own. Try letter E. I'm sure you could. I bet you could do it. Okay, so first thing I did was rewrite it. Instead of the third root, it's got a power of 1/3. The outside was something to the 1/3 power. So power rule says, move 1/3 to the front, subtract a whole power, makes -2/3. Rewrite the inside, chain. Now find the derivative of the inside. Derivative of the inside is just 12x. Done. Last thing you're going to do, I'm going to multiply 1/3 times 12x, which is just dividing by 3. If you multiply by 1/3, you're just dividing by 3. So that's going to be 4x. So it's going to be 4x times 6x squared plus 1 to the -2/3 power. Well, I can't finish with a negative power. So how do I change that? You move it to the bottom. So we're going to have 4x on top, 6x squared plus 1 to the +2/3 power. You can move the root back in. So another way to write this is like this. The square root, or the third root of 6. That's another way to write it.
Could you go back to the top? Thank you.
Okay, I'll tell you right now, the biggest problem, the biggest part where students get tripped up on is this part here and this part here. They forget to, or they don't know that I got to change the root to a power. And then after they do the calculus, they don't know, like, oh, how do I reduce this? I forgot to move this guy in. It's not the calculus part that trips up students I've seen in the past. It's the before and after calculus. Okay. All right, let's try the next one. Again, we're looking for grouping symbols. Grouping symbols means anything that is grouped together. The last one was a root. This one doesn't have a root, but it has a fraction. Fractions can be grouping symbols. So the bottom is the top is a grouping symbol. The bottom is a grouping symbol. So why did I write a fraction? 4 minus 5x minus x squared to the -1 power. Okay. Something to the -1 power. Well, something to the -1 power, I would move the power to the front. rewrite everything that was in there, subtract a power, chain. Now I got to find the derivative of the inside. Well, the derivative of 4 is 0. The derivative of negative 5x is negative 5. The derivative of x squared is 2x, so minus 2x. Done. So this time the derivative is a binomial. Before it was just a monomial. So what I'm going to do is two things. First thing I'm going to do is I'm going to move this guy down because it's got a negative power. So it came from the bottom, so I'm going to move it back down to the bottom. But now it's going to have a squared to go with it. So what stays on top? Negative 1, and then the binomial negative 5 minus 2x. So you can leave it like that or distribute. Personally, I don't care which one you do. You could leave it like that or you could distribute. The big thing is, like I said, if you're taking a multiple choice test, sometimes they'll distribute, sometimes they won't. So if you distribute this guy, that's okay with me. If you leave it alone, that's okay with me. Right? Because distributive property is something you guys have been doing since junior high. I'm not concerned about that. I'm checking the calculus part. Okay? Just don't leave it like this. That's all. Just don't leave it like that because you won't find an answer like that. If it's a multiple choice question, A won't look like that. B won't look like that. C won't look like that. D won't look like that. They'll either look like this or they'll look like that. Okay? All right, G, letter G. This one's got both. It's got a root and a fraction. A root and a fraction that I have to take care of. So how do I rewrite this one as? There you go. Quantity 3x plus 5 to the negative 1/2 power. Underneath the root means negative power. Root means, or underneath the fraction, sorry. In the denominator means negative power. Root means fraction power. Okay?
Wouldn't the negative be the fraction and the root is the
Yeah. Okay, so here we go. G prime, something to the negative 1/2 power. All right, negative 1/2.
so the negative 1/2?
It's to the negative 1/2, so I'm going to have to subtract 1, right? So it's going to be negative 3/2. Chain.
Times 3?
Times the derivative of the inside. The derivative of the inside was positive 3. So we're going to have a fraction here. I'm going to have a 3 on top, a 2 on bottom with this guy. And then I have a negative as well. The negative you can put with a 3, you can put with a 2, or you can just put in front. Just know there's a negative there. Okay. The only way for this to get harder is by putting different layers. Right now we've only seen 2 layers. We've only seen things with 2 layers. I've only gone 2 layers deep. It is possible to go 3 or 4 layers. You won't see that a lot, but it is possible. So on the next page, we're going to have, there's some that go a few more layers deep. I think they go 2 or 3 layers, or 3 or 4 layers deep. That's the only difference. So it's going to have various insides. It's going to have an outside, then an inside, then another inside. Okay, that's the only difference. Again, the hardest part is figuring out which ones are the outside, which ones are the inside, and all that good stuff. Okay? Example number 3A. 3A. What do I have to do before I can do anything here? So there's two things I have to do. There's two things I have to do. That third, I got to find a place for to put the third power, and I have to change the root. So what is that going to look like? It's going to look like this. So f of x so the whole thing is cubed. So that's where the third power is going to go. And then on the inside, because the root only goes with 4x plus 1. The root doesn't go with sine. The root only goes with 4x plus 1. So that's why it's got to be on the inside. I can't multiply as much as you want to. You can't multiply 1/2 times 3 to make 3 1/2 because we don't touch root, or we don't touch, this guy is the angle, off limits. Okay, so now that we did that, let's look at the outside first. The outside is going to be something to the third power. This one has 2 layers deep. Oh, 3 layers deep. Yeah. So now the inside. So we're going to go inside one level. And that's going to be sine. Sine of something, right? Yep. Sine of something. Sine of something.
1/2 of something.
There you go, right? So now we're going to go inside another level. It's not 4x plus 1. The next level is actually something to the 1/2 power. Something to the 1/2 power. That's the next level.
So there's 3 insides.
So in the last one, there's still an inside, right? Something I haven't touched yet. 4x plus 1, which is inside the inside parentheses. So this guy here. 4x plus 1. So this one has 3 levels. The shell, the chocolate, something inside of there. Something inside of there, right? It goes deeper. 2 levels deeper than we're used to. All right? The ones that we were used to just had an outside and an inside. And most of the problems you guys see will just have an outside and an inside. That's it. But there will be a few that you have 2 insides or 3 insides like this one did. Okay? Okay, so let's take a look at B, 3B. Nope, not yet. We'll do derivative on that one in a second. I just want to focus on, derivative on that one I'm not worried about right now. We'll do that in a second. What I'm worried about right now is levels, because if I don't know the levels, then I can't do the chain rule. So how can I rewrite this guy
-3/2.
so I'm happy? Okay, so that's the hardest part, rewriting it. So there's 2 things I don't want. I don't want a fraction, and I don't want a root. Okay, so I'm going to take this one in parts. I'm going to take this one in stages. So the first thing I want to do is change the root to 1/2, right? Because it's a square root. Wait, no, sorry. because it's the whole thing is under the root, not just the 4x plus 1. The whole sucker is under the root. Now I got to move that up. Oops. 3 times tangent 4x squared plus 1. And instead of 1/2, it's going to be negative 1/2. Okay, so let's do layers now. Outside layer is 3 times something to the negative 1/2. That's the outside layer. 3 times something to the negative 1/2. That's the outside layer. Okay. Let's go in one part. Let's go in one layer. What's the next layer going to be? Tangent. Good. Tangent of something. Tangent of something. Tangent of something. Okay. What's the next inside layer going to be? 4x squared plus 1. And that's the last layer. This one's only had 2 inside layers, so it's not quite as long as the other one. Okay, not quite as long as the other one. So this is kind of a roadmap. Now what we're going to do now is we're actually going to find, I don't think we'll have time today, but tomorrow we're going to do 4a. Okay, one second, let me finish this and I'll answer. This is a roadmap into what we're going to do. Right? What am I going to do first? Find the derivative of something cubed. Chain. Find the derivative of the sine of something. Chain. Find the derivative of something to the 1/2 power. Chain. Find the derivative of that. It's kind of it's a roadmap on how to do the problem. So we'll come to. So once you have this, it's not nearly as hard as before. This is the hardest part, finding the inside layers. Yeah, JJ?
I was wondering, you know how you put the outside, you put 3 something to the power of negative?
Yeah, the green one, yeah.
Can't you just put it to something to the power of -3/2?
Where'd you get 3/2 from?
It's because
Yeah. When I find the derivative, yeah. I'm not finding the derivative yet, but when I find the derivative, the first thing I'm going to do is move this guy to the front, right?
Because what you did is you did the bottom, you did the square first. I did the top first, like the over 3. I made it a -3 to the power of -3 first.
So you have 3. I see where you get the 3 on top, but you said you had a 2 on bottom?
No, like look over here on the paper.
Yeah, what's it?
But you know how you did the square first. It said I did the top, so I made it to the power of -3, and then I did the square.
So that 3 is not a, so we can't do -3 because it's not a -3 power.
But I thought for whenever, like say it was like a 1 on top, like for example, you would change it to you'd put all this into this, and then make it a negative power.
Just to move it up.
That's what I did for this one.
But that 3 right there is not a power, so we can't move it to a power. We can't make it a power.
But I thought that's how we do for other ones, no?
No.
See how we took it, we moved it to that.
Oh, that had nothing to do with why. That could have been anything, and it would still have been -1.
Still,
If that was a
always-
3, yeah, just moving it to the top
Oh, so
is just a negative whatever power it has, yeah. Okay. All right.